Lesson 13 and 14 is about the angle sum of triangles. So we're going to start with how you name the angles within a triangle. And most of you are used to seeing things like this, where we have a little angle sign and followed by some letters. And that's just telling you which angle we're talking about. So this one right here, angle ABC, the way that you tell which one we're talking about, because there's three to choose from, you start with the first letter, go down the second letter, and to the third. So ABC is talking about this angle right here. So let's color that in. So angle ABC is this red one down here, okay? But couldn't we also go the other way? Couldn't we also go CBA to name that angle? And you're absolutely right. So the second one, angle CBA, is the same exact angle. Just normally you tend to see them in alphabetical order. But it is the same, and you're absolutely allowed to call this angle CBA opposed to ABC. What about the other angles? Well, next we have CAB. So which one is that? So we start at C, go up to A, and then down to B. So that one that we essentially kind of went through is this one right here. And once again, instead of going from C to A to B, we could go the other way, B to A to C. And that's the exact same angle. So those are both still how we could call this green angle. You might be noticing something. Here we have B in the middle, which was this one. Here we have A in the middle, and that was angle A. So thinking about these ones that have C in the middle, that's going to be angle C. So ACB, ACB is this orange angle down here. Of course, you can be color coding them a different way if you would like to. And then angle BCA, BCA is also this one down here. Okay. Now, you might be thinking, well then, if this is all really just angle B and angle A and angle C, why don't we just call them that? Well, you really have to think about the fact that this is a very simple example. Once we get more like lines coming off this and other things going on, you do need those three letters to let you know exactly which one you're talking about. So as an example, you do not need to write this down, but what if there was a line coming off here? And I wanted to say, well, what's the angle of angle C? What's the measure of angle C? Well, am I talking about this interior one or this exterior one? Okay, and that's one of the reasons why we want to do all three letters, because if I have this point out here, D, if I wanted to talk about this exterior one, I could call that A, C, D, and that would be that exterior one, opposed to the interior one, which is A, C, B. So you can pay attention to the middle letter to know which one you're talking about, but you need to be careful if we're also including exterior angles as well, in which case just doing the middle letter might mess you up a little bit. Now let's finish up the sentence down here. The sum of the interior angles of a triangle is, so it's just asking if I took the measure of this angle plus the measure of this one plus the measure of this one, what do they all add up to? And interestingly, all triangles add up to the same amount. They all add up to 180 degrees. All triangles, their interior angles, are going to add up to 180 degrees. Okay? And as you get into high school, you'll notice that all similar shapes are the exact same way. Not that they add up to 180, but they all add up to the same amount. All square interior angles add up to the same amount. All pentagon interior angles add up to the same amount. So now that we know that the sum of the interior angles of a triangle is 180, we can use that fact to find any missing angles we might have of a triangle. So here we have triangle ABC, and we have that angle A is 64, angle B is 83, and we need to find the measure of angle C. Well, that's pretty simple. If we know that all of them are supposed to add to 180, we can just find what's missing. So let's add up angle A, which is 64, and angle B, which is 83, which is 147. So now we can just take that away from 180, and we can see that what we're missing is 33 degrees. Well, then that must be C. So we know that angle C is 33 degrees, or in the way that they're calling it, angle ACB is 33 degrees. Let's take a look at another example. Here they're asking for the measure of angle EFD. So EFD, so we're looking for this angle down here. Well, once again, we can use the fact that all of these angles inside need to add up to 180 to figure out what's missing. So we can add together our 101 from angle E and our 40 from angle D, and we get 141. So now we can take that away from 180 to see what's missing. And we find that 39 degrees is missing, so that must be the missing angle. So we just found that angle EFD is 39 degrees. Now let's take a look at what happens when things get a little bit more complicated. We're still finding missing angles, but it's not always of an interior angle. It might be of an exterior angle, like in this example right here. So we're trying to find x, which is right here, but we aren't really given much. We're given that this angle right here is 44, and we're given that this angle right here is 32, and I'm going to write those again because it's really small. So how can we find the exterior angle? Well, there's a couple ways. We can kind of do a slow process of, well, if we know these two, then we can find this interior angle. So let's find that interior angle, because once we find the interior angle, then of course we know what the exterior angle is because we know that straight lines are 180. So let's add together 44 and 32. So we know that those two angles together is 76 degrees. So now we can find out what's missing to find the interior angle. So we need to do 180 minus 76, and that's 104. So this interior angle is 104 degrees. Well, if every straight line is 180 degrees, well, we know that this is going to be 180 minus 104, which is 76. So this angle right here is 76 degrees. That exterior angle is 76 degrees. Now some of you might be like, wait, 76, we saw that somewhere. You're absolutely right, we did. 76 was the number we found when we added up the other two interior angles. And that's actually one of the tricks to this. If you have an exterior angle opposite of the other two that we do know, all you actually really need to do is add those two up. So if we do that trick, we can eliminate two whole steps to finding that angle. But of course, you can still always go through the process of finding the interior one and then subtracting that from 180. That will always work. But if you want to do a fast way, almost a little quick trick, all you have to do is add up the two angles that you do know that are opposite from the exterior angle. So let's see if that holds up in the next one. So here, once again, we have two interior angles that are opposite an exterior angle that we're trying to find. This one right here is 14 degrees. And this one right here is 30 degrees. And we need to find what x is. We need to find this guy right here. If we do our fast trick, all we have to do is add up these two angles. All we need to do is add up 30 and 14, and this should be 44 degrees if that trick holds up. So now let's do it the long way to check that that actually really does hold up and is 44 degrees. Well, our first step would still be to add those two up to get that 44 degrees. Now we'd have to subtract it from 180 to find the missing interior angle. And it's 136. So this interior angle is 136. Then because this is a straight line, these two should add up to 180. Well, is 136 plus 44 180? It is. So we just proved that that initial trick of just adding these two angles together does work. But again, you can always just do the longer way, adding these up to find the missing angle and then find the exterior angle from that. Now let's take a look at even more complex problem. We have more than just a triangle. Here we have even more lines. There's still a triangle inside, which is good because we know some things about triangles, but we have other information as well. And so that's why we should always read the instructions, because it's not always just what we're doing, it also tells you a lot of good information. So the instructions say, in the diagram below, lines 1 and lines 2 are parallel. That's good to know. We just learned a while ago that there's some interesting things that happen with angles when lines are parallel. So the lines that are parallel Then we have transversals R and S intersect both lines at the points shown below. Determine the measure of angle JMK. So let's find where that one is. Here's J, here's M, and here's K. So we're trying to find this angle right here. And then explain how we know we are correct. Now there's a lot of things going on here. For one, we know that this interior angle is 39, which is great. We're trying to find another interior angle, and we have one already. So that's really great to know. But maybe we need to find another interior angle. Well, they don't give us many angles besides the 39, but they do give us one more. They give us this one right here, which is a 72. So it might seem hard to figure out what this is, because yes, this is a straight line, but we don't know this missing piece over here. But because there are parallel lines going on, we know some other angles that are also going to be 72. Because of our rules with parallel lines, this angle is going to be the same as this angle. So it's going to be the same as this angle because they're corresponding angles. So from there, we know that this angle is also 72 degrees. And you might be thinking, well, okay, that doesn't help us that much. But we can keep going and just fill in as many angles as we can. So what else is 72? Well, when you have parallel lines, you also have that the opposite angles from a transversal are also the same. So this guy right here should also be 72 degrees. Oh, well, that's the other interior angle we need. So now all we need to do is find the missing interior angle by adding up our 39 and our 72. It's 111, and if I got that wrong, please tell me in class. So here, this is going to be our 111 degrees, and we're all done. Okay, so when we come to more complicated things like this, we're going to be using a lot of the facts that we know. The fact that straight lines are 180 degrees, the fact that interior angles of triangles are 180 degrees, and then all that stuff we found out last lesson about what happens when we have parallel lines. And that all just comes together to solve things like this. And we'll be doing more examples of this in class. And that's it for this lesson.